Oscar.
Yes.
I think we start now because it's been 6 minutes and we I don't want to waste people already here. I don't want to waste their time.
Okay, so, let's go. Yeah, let me show a screen. Okay, so let's start. I want to introduce our company, technology, and all how Tempris can easify your LIO process. How can make it more transparent. How can help for optimize. How can help for control your cycles from formulation to scaling up, transfer, and commercial applications. And how easy it can be with Tempris. This is people hear about Tempris and say, okay, this is a real-time monitoring product temperature, and is based is no battery, no cable. However, it works. How it works. This will be also another point that we will discuss. How does technology works, and what advantages can offer us, like thinking in the next one coming fully automated sensor technology, no human interference for loading, completely process automation in real-time data with our software, also integrated in the freeze dryer control system, and continuous process monitoring can be done easily in all normal commercial batches. So here I put several topics that we can talk about. We can do questions at the end if there is any question rising, and we can also discuss between the conference. So basically, let's start with a company history. Now, who is Tempris? Tempris, it was called IQ Mobile Solutions because we start with the automotive sector for pressure, tire pressure monitoring in wireless. We offer our solution for many manufacturers. And that time before now is actual and it's well-known, this available solution. But in that time was quite modern. And then one pharmaceutical company from Germany say, I want this wireless technology for lyophilization. So we adapt our product for lyophilization, CGMP compliant, and all requirements for pharmaceutical applications. And we start in the sector in 2009. The system, the third generation, is already launched in 2018. And one of the changes that we made, because everybody knows Tempris, but nobody knows IQ Mobile at the beginning. So we changed the name to Tempris. The company is exactly the same, and now our name is Tempris GmbH. Well, we have a global presence with partners around the world. We have also collaboration with Gilios and Explicat. We have a company called Get. Basically, is for offer the complete support for our customers, starting from support in formulation with Gilios, Henning Gisseler, who is a well-known person in the lyophilization world. And he is supporting also for special products and generate new recipes and anything about preclinical and formulation test. And then we have also Explicat, where they are experts in regulatory and to bring the product to the market. Together with Tempris, we also can offer these additional services to our customers. Where we are, so we are located in the south of Germany, and we have agents and partners around the world. We have many systems installed also in of course in Europe and US, but also in Japan and Korea. And India. We are from many years already. Taiwan as well, and China. So coming back to the main points, sorry. Let's talk about a little bit about technology, because we want to know how does it works. Basically, this is a radio frequency technology, and then the sensors have no battery, have no cable, have no energy. So how the sensor works? Basically, we have a main measuring device, which is generating the radio frequency signal and is getting the data from the sensors. We have interrogation antennas, which is the way for sending this and catching the signal of the sensors. And we have the sensors where are placed normally in vials, in bulk, and different applications, no, for measuring the product temperature. Also, we have a laptop. The laptop could be provided by Tempris, a fully configured laptop for getting the data of the system, configuring the system. Or also we can use, customers are using virtual PC, so the system connected to the server, or also the customer can use their own by following some basic specifications. The technology works as follows. The main interrogation unit is generating a radio frequency signal between 2.4 2.5 gigahertz approximately, and is radiating this radio frequency via interrogation antennas. No? These interrogation antennas could be installed inside, outside. Normally, we prefer always inside of the freeze dryer chamber. But also we have small applications, lab pilot freeze dryers, which have side glass or acrylic door. So we can also use external antennas. The radio frequency goes through antennas and radiates inside of the chamber to catch the sensors. The sensors have also a very thin antenna in stainless steel, which catches this signal and brings the energy to the sensor. We are sending a signal around a 1.1 watt, so it's insignificant power energy sent via radio frequency, but it's enough that for getting the quartz, which is located in the bottom and the bottom of the sensor, where is the measurement point, is enough to start oscillate. This quartz starts to vibrate. No, it's getting the energy by radio frequency, and this oscillation that he is suffering, no, is directly proportional to the product temperature. So depending on the product where the sensor is submitted, in which temperature is the product, this oscillation change. And this behavior is carried out by the antennas to the system, and the system convert this oscillation, this behavior, in a very accurate temperature. So I say very accurate temperature because we are talking about the complete system, antennas, interrogation unit, and sensors we are offering as a standard in the range of accuracy of plus minus 0.7 Kelvin or Celsius degrees. And also we can offer 0.5 and 0.3. A basic configuration to have an idea, the main components. We have external components, which is the main interrogation unit for production or commercial freeze dryers. Normally we install in top of the chamber. It's covered with IP44 housing, metal housing, included the power supply over Ethernet, and could be single or double unit depending on the freeze dryer application, on the number of the antennas that we need. Then we have the software. The license are installed in the main interrogation unit, and then we have the visualization software, which have to be installed in an external computer or freeze dryer control system PC, and the one that with different license depending on the application. Of course, we have different for number of sensors, for number of antennas, for requirements of 21 par 11 CFR par 11 compliance, etc. And to monitor the temperatures in real time. Then on the other side, inside of the chamber, we will have the antennas. For example, here I'm showing the new MF antenna, which is a tube with all the antennas fully integrated. In the cables, you cannot see cables, everything is going inside and connected outside of the freeze dryer. Also, we have another solution of antennas that I will share later. And then the sensors, the sensors which are placed in the vials or in bulk or whatever is the necessary, the primary packaging that customers are using. The software allows, we have different licenses for the software. We know that it's showing the temperatures in real-time monitoring, showing which antennas are catching each sensor, showing which sensor are with the serial number, and showing all in real-time monitoring the complete cycle that we are measuring. We can export and we can manage this data during the cycle as well. We can export to CSV file because while the cycle is running, etc. And then everything could be complemented with additional software license and documentation, like we can integrate these signals to the freeze dryer control system via Modbus, Profinet, Ethernet IP, as well for 20 milliamperes, the traditional wired signal. The documentation that we can release together with the system is the normal commissioning certificate, but we also can offer IQ-OQ installation and operation qualification. We can offer quality plan. We can also offer services like ramp up, to get the system used and get the benefits as soon as possible, as soon as the customer is using it, and et cetera, et cetera. And the software is available in different languages, including the traditional Chinese as well. Here, just to show how it looks, one antenna installed in a large freeze dryer with this new technology. In the left side, we have this MFA antenna. Of course, everything that is installed inside of the freeze dryer will be SIP with C and SIP with S, clean and sterilization in place process compatible. The new antenna is low maintenance. You don't have any cables, no possible damage of the cables during service of the freeze dryer, for example. Everything is fully integrated in a tube and everything is put at pressure atmospheric outside. The antennas are provided in 316L material with a roughness better than 0.8, easy to clean, and with helium certificate also, that everything is completely sealed to avoid any leak in the freeze dryer. In the right side, we have an example also from the traditional antennas, which will be normally for retrofit solutions. We can offer a rod with some clamps, and we can attach these antennas in parallel of, for example, any vertical CIP pipe. Or when it's a new freeze dryer, also the manufacturers are building special rods inside, always stainless steel 316L, to clamp these antennas. I have more photos later on about these antennas to show how it looks. Here, an example how we install the antennas. The cables are inside. We can fix in this tube connection pipe, the antennas pipe, and everything is connected outside. And outside, we have the main interrogation units, one or two, put it on top of the freeze dryer and connected with the flange to connect these cables that we see inside the antenna to outside to the main measuring device. So this is the wired part, let's say, and inside of the chamber, we have between the antennas and the sensors, we have the wireless part, the radio frequency communication. The type of sensors. The technology it doesn't change, but we can change the body or the form of the sensors according to customer specifications. So as we can see here in the picture, we have sensors in different sizes. The main reason of the sizes is because we have to keep always the top part of the sensor where the sensor antenna is attached have to be always above the liquid. The liquid is an enemy for radio frequency. The liquid is a physical phenomenon. Liquid absorbs the signal. So we have to keep always different sensor lengths in order to avoid that the sensor get immersed in the liquid. As soon as the sensor is completely immersed in a liquid, we will lose the signal. That's why we have to keep upper part out over the liquid. Approximately 75% of the sensor body is the maximum filling volume for every sensor. And the most important thing to remember, the measurement point is always in the center and in the bottom, where is the remaining ice during sublimation. Is the most important point. And we have the specific accessories like a center crosspiece antenna together with the stopper in order to measure center and bottom and not in the edge or the corners of the vial. The sensors are available for all type of vials, from standard air-H vials, from 2R to 100H vials, for example. We have also solutions for double chamber cartridges or syringes, like here on a photo in the right side. We also have solutions for LyoGuard, this Gore membrane trays for bulk applications. And we also have solutions with a special holder, keeping the sensors over a shelf, over a tray for bulk applications, for trays, the single use, typical plastic trays, or metal stainless steel trays as well. The accuracy of the sensors we talked about already is plus minus 0.7 Kelvin as a standard, and we can offer also more accurate until up to 0.3 for the complete system, not only for the sensors, it's important to mention. And then the sensors could be clean and sterilized, and all this information is specified in that product data sheet. Now we also have a large demand for many customers are having oncological products which require specific clean methods, also have cytotoxic products. they don't want to reuse the sensors, and we have a large demand of single-use sensors. And we are preparing this solution, and we expect that will be soon available latest beginning next year. It will be the same technology, the same solution, but single-use sensors. So you can use one time for measuring a cycle, and then you can replace it. I want to show one of the important things is how to prepare the sensors in order to get the sensor assembled with the stopper. The stopper, sometimes in the videos that we are showing, it shows another color, but the stopper could be exactly the same that the customers are using. We don't need any specific stopper. We can use the standards, and we have different cases where we have customers with different stoppers. The rubber stopper could be used. We don't need any specific holder or part to hold the sensor in this vial, for measuring center and bottom of the sensor. Let me show you this video. It shows how to prepare the sensors and how to get sterilized and clean inside of the where we want to put the in aseptic area, no? I assume that you cannot hear, no, the video?
No, we cannot hear.
Let me try it with this. I disconnect the other monitor. And now?
No.
Also not. Okay, then I switch off the volume, and I will put my voice. It's better the voice than for the video, but I will use mine in this case. So basically, a short introduction about our technology. Basically, the video is saying that we can measure center and bottom of the vial. Where is this small pin of the sensor is the measurement point. Here it shows the parts of the sensor, center crosspiece, specific for every size of vial. And let me go back. It's faster than me. Center crosspiece is specific. The only difference is the length of these arms that we can see is in order to keep the sensor centered inside of the vial. So for bigger vials, of course, the center crosspiece will be longer. And it's made in PEEK material, so it's suitable for sterilize and to be in contact with the product. The other part is the sensor antenna, is something like 50 millimeters length, the standard sensor antenna, and it's stainless steel and it's 0.3, 0.4 millimeters diameter, so it's very thin to allow the stoppering process without any complication. And then the stopper, as I mentioned, is the standard for every customer. Then let's see how to assemble everything, starting for assembling the sensor, center crosspiece and antenna. And the second step is with the new semi-automatic piercing tool, how to assemble all together with the stopper, keeping this distance, the necessary distance from the stopper to the sensor already configured from the beginning to avoid that we are placing like the traditional method, we place the stopper with the sensor and then we have to push the antenna down until the sensor reach the bottom. With this new piercing tool, you will see that it's not necessary anymore. But this is a special holder in aluminum. We put the antenna inside, we put the center crosspiece, and we punch all together with the sensor. So the sensor is ready for piercing tool, means to put together with the stopper. Here we adjust the best position for the sensor according to the stopper. We fix it. We open the locker for placing the stopper. We have different pieces here. These metal pieces could be for 2 air vials or for the other vials, even for the large ones. We have 3 sizes. We go through with the needle through the stopper, and then we go with the sensor antenna through the needle and in the right position. We keep the right distance. We remove the needle. We remove the locker distance. So we have everything already integrated with the stopper, ready for autoclaving. No? This is not a sterile area. We are working in an area not sterile for preparing this. As soon as everything is ready, we put in a special holder, which could be configurable depending on the length of the sensors or stoppers, etc. Could be adjustable. It's basically a holder that we will place all the sensors. We protect the sensor antennas from top. We cover everything with a steady bag, a medical bag for autoclaving, and then we bring to autoclave. Going out from this autoclave, we are in the aseptic area. So we can think about this image looks like an autoclave and also looks like a rapid transfer port to go inside of the aseptic area, no? The loading area of the freeze dryer. When we are already in the aseptic, area, basically we only have to remove with wraps, no, the back, the protector. And then here we have the two options. This is the option semi-automatic. So we have special tweezers for changing the stopper of the vials in the loading line. Or we have the robot that I will show a video later on, how it works, this robot in a fully automatic version. No? With this forceps, we take the stopper and we take the sensor. We also can identify, we can put a reader, identify which sensor is going in which vial. We put in the vial, and then it goes the line to the freeze dryer. It's a process quite simple and allows us to do it in a normal commercial batches as well, not only for validation or not only for lab applications or formulation, which we don't need. So many times we don't need this stereo area. Talking about the sensors or the technology, this is important to mention the comparison with another technologies. We always have this comparison, and we are look at this image. It was a test from Pfizer in Chip Talk. They were testing different solutions, and I take just a page here to show the comparison Tempris versus thermocouples. No? On the top, we have an image of a cycle measuring in the center of the shelf, and on the bottom, we have measuring at the edge of the shelf. As we can see, Tempris have an excellent overlay of freezing, and is following exactly is always in contact with the ice. So that's why we have this difference between another technologies. As you can see, the red line is the other technology, and the other technology starts to sublimate before than with Tempris technology. Especially in the edge, we can see that they are crossing the set point of the product shelf temperature. The thermocouple is crossing before Tempris. No, why that happens? Basically, the following. First of all, many other technologies are not measuring exactly in the center and the bottom of the vial, where is the remaining ice during sublimation. And this is very important. If you are measuring in the edge of the vial, in a corner, the ice is sublimated just much earlier than, because it's directly in contact with the tray. No, have not this bended part of the vial in the bottom, so you will not have the really control of the remaining ice, no? When we can finish with the primary drying, let's say, in other words. And the other thing is also we have no heat input to the product. Tempris is a battery-free. There is no any resistance. There is no any cable. So there is no way to bring heat to the product. So it means we are not making that this vial with the sensor sublimate earlier than the other vials, because we are not bringing any heat input. It doesn't happen with another technology. No? They have maybe some resistance. They have a battery. They have a cable going from the battery to the measurement point, and this cable is very near of the upper shelf, for example. So the upper shelf is radiating also some temperature to the cable, which goes inside, even when it's insulated. It goes inside to the point of measurement. So at the end, we can find out that this is not the real product temperature, because we are not measuring exactly. We keep the contact always with the ice because of this missing heat input. But the other technologies, we assume that they are losing the contact. They are generating a space between the measurement point and the ice. And that could be also the third reason that they start to sublimate before Tempris. Another difference, of course, with Tempris technology versus others is Tempris technology is very easy for loading and unloading, using in automatic loading lines. We only have one sensor per one vial, and we don't have to take care about batteries or cables or any other technology, or other parts that technologies have. No, the measurement point I mentioned, same stoppers. This is very important. We are not changing the sublimation flow. Of course, we have always some body inside of the vial. And this is also always to be considered, even when it's a very thin one, like thermocouples. But we are using exactly the same stoppers than the other vials. So we are having the same rate, sublimation rate, or the same space for getting out this humidity or this sublimation flow from the vial. Moreover, we have one sensor, one vial. So all the surrounding vials around this measurement point will be vials with liquid, not will be special holders or batteries or another type of part that another technologies have. So we are measuring in a point and we have the surrounding vials in the same condition. So we are more accurate also in the real what's going on inside of the freeze dryer about temperature. Battery free, it's okay to know, and it's especially important when we have and other technologies. You have to always be sure that all batteries are okay. You have to replace maybe every cycle. You have to take care when the cycle you have a long freezing time, or for example for tau freezing applications where they keep the product in a very low temperature during long time, they will run out of battery probably, and we don't have this problem. The cycle could take 2 days, could take 1 week. In the temperatures is not a problem. We have, for example, a standard range calibration from -70 to 70, and we will have no problems with battery. And then, of course, real-time monitoring, as I mentioned, you have the values instant at the moment, no, in real time. You don't have to wait until the cycle is done and take the sensors, put it in a special loader or table and for getting the data and then export to the other formats. We have the data at the same time that is generated. So we close the door of the freeze dryer and we know what exactly is going on with the product in these critical positions that we recommend to measure.
Sorry, Oscar. Could you show the software page to maybe it will be more clear on what you just said, how we see the temperature is saved and real time.
Okay, I have 2 options, Ling. I have a demo version of the software that we can show at the end of this presentation if you want. So I can show how to connect with the system and how is the data coming. Of course, it's a simulation software. Or on the other side, I can show you here detecting the critical positions in the hot and cold spots. I have a short video that shows how the temperature change and how the graphic is moving. Whatever you want, we can put. Let's maybe better left this demo software at the end, and let's continue with the presentation on these images. If not, of course, we have this the different graphics here, and we can see how it goes. And we have a short video that shows how the temperature is going and how it's changing for different positions in the freeze dryer.
Okay.
Okay. So let me continue here. One of the important things that we need to know is the detection of these critical positions. That doesn't matter which freeze dryer size or company or brand we have. All freeze dryers always have different points. You get different temperatures inside during freeze drying cycle with product. This is called the hot and cold spots. No, the hottest during freezing and the coldest. No, sorry, the hottest during freezing means the points. The points that are getting lower temperature or are more critical for getting frozen, or the coldest means the remaining ice, where is the ones that takes more time to remove the ice from the product, no, during freezing, during primary drying. Sorry. So these positions are always. We have many experiences with different freeze dryers and applications, and we know also that if the condenser is in the bottom, or in one side, all the shells or areas near of the condenser will be probably the coldest point. Normally, the top of the freeze dryer is the warmest point, but then also it's more to be considered if we are in the center of the shelf. All the one vial is covered with all the other vials, so the coldest point will remain longer in the center of the shelf probably than if this measurement point is in the corner or in one edge of the shelf, which have very near the freeze dryer chamber walls, which are in another temperature than the shelves where the product is held. So we have different also the loading door, we call pizza door, no, the loading door for automatic systems. It's also not having the same insulation material. How is coming the silicone oil to the shells? If there is a manifold inside or outside of the freeze dryer, inlet, outlet, we consider all the phenomena for every specific freeze dryer, and we recommend some measurement points in this freeze dryer from the beginning. No? And then it's not really necessary to do the 5-star pattern, no, 5 sensors per shelf, typical for measuring in all the shelves. So maybe we can do, for example, here we have a customer that he wants to keep the 5 sensors, but he keep only in top, middle, and bottom shelves as a reference. It was a freeze dryer with 9 shelves, 20 air vials with 6.7 ml, and they want to measure 5-star in top, middle, bottom shelf, and 1 additional sensor in shelf 5. We put the antennas in this freeze dryer in these different positions. We have this configured before, and then we will see what was the results. I want to also introduce that the software will have very soon available one application that allows you to configure in our software all the measurements or all the information about your freeze dryer chamber, also about your product as well, we will see later. And the reason is that when we have then the cycle done and we want to export to the log file report, we will be able also to show this information. No? Where was the location for sensor number 1? It was in shelf number 1, for example, in the corner right from the service door, or in the center of the shelf. So all the information will be in the same document to make it easy, the analysis, the post-analysis of all this data, no, for validation runs, or also for normal, for all batches that we are measuring. So this is an example. We have, let me stop 1 second. We have here a freeze dryer with 4 antennas placed. We put the sensors in 5-star patterns as a demonstration, and we cover with, this is a holder, but basically the color is to identify easily the color. And the color means if we are going to blue, means we are going to plus up to -5 degrees of the average of all sensors temperature. The average will be more or less in green color. And if the sensors that are going over this average temperature, plus, for example, more than or equal 5 degrees, will get in red color. No? So we make this run cycle going down to -50 and then increasing the temperature to 40. And we will see how we change the colors during the cycle. And this is, we can see also in the graphic, of course, the difference of temperature from one point to the other. For example, here we have sensors at -45 and others at -55. It's easy to see also, but the visual view helps a lot to identify immediately where are the critical positions. Just have a look at this video. Here is the temperature. It's coming. We are going a little bit more down with the temperature. Here we have some hot spots in these corners, top shelf. And then we increase the temperature and everything starts to change. And we will find out the coldest points are here in the center mainly, and the warmest were in the corners until we stabilize. We get a stabilized temperature at the end. So basically, it goes a little bit faster, but we can play a little bit again. For example, when the temperature is coming again, coldest points in the center, maybe warm point on top corners. And when we are in this phase, I will stop. When we are here increasing the temperature, we will see where are the coldest points. We can see, as mentioned, the center of the shelves are covered with the other vials. So normally this temperature is the coldest point in the freeze dryer, and see the corners where no vials covering these measurement points are the hottest. So are sublimating early because they have the radiation walls, also temperature, which increase the temperature faster. So I think, Lynn, I think this shows a little bit also what you want to see of the graphic, but I have also the demo software at the end of this presentation, which is changing the temperatures aleatory, and we will see also how it works, our software, how easy it is to manage our software.
Okay.
Okay, so we talk about technology, we talk about detection of these critical positions, which we consider very important for measuring in real where we want to measure, where are the critical positions. Let's go to scale up and transfer. So one of the important things also about our technology is could be used in all the steps in life of our products. We can start from formulation and development in a tabletop freeze dryers, in very small freeze dryers. We have solutions also with a single antenna and a set of 5 sensors for measuring here. And then from here, we will keep the same technology, as I mentioned before. The only thing that going from bigger and bigger and bigger freeze dryer, we need to update the antenna solution. The software works in the same way. The sensors are exactly the same. So we will be able to compare from formulation, preclinical test to scaling up or transferring to our CMOs or transferring to our production sites. We will be able to use the same technology. So we will compare apples with apples, the same effect of the sensor inside of the vial without changing from cables to thermocouples to whatever. We can use the same technology. So we have this tabletop solution, then we have the similar one with for a lab pilot or scale freeze dryers with a little bit more antennas, and then we have the fully integrated, also up to the fully integrated solution for commercial freeze dryers. What we can do with our technologies, so from lab scale commercial at the end, we can start also with the typical shelf mapping in dry conditions. We have special holders for measuring this, but this is not the main intention. There are other technologies that can do also without product, can measure also, but also Tempris can help here. But the most important things are we are in formulation development. We can easily identify the critical positions because we can measure everywhere in the freeze dryer and configure then the antenna installation accordingly. We have customers that are using the technology for process validation. We have customers that are using our technology. They have different equipments and they are going with equipments in his CMOs for testing the cycles with Tempris in different freeze dryers. Of course, and we can do also PPQ, and we can do also continuous process verification or monitoring in the commercial batches. We will talk about this because why we have to measure in a commercial batch when everything is defined and the recipe is clear and everything. I will explain you what is the advantages also to get Tempris in your normal batches, just measuring in these critical positions. Let me jump here to the deviations. This is a very important thing that I start to talk. Why is important to measure in normal commercial batches when everything is defined, the recipe is defined, the product is stable, etc., etc. So it's always good to have the information, the data. That maybe it's difficult to change the recipe when everything is validated, but if you are measuring in the cycles during normal cycles at the end, you will get all the temperatures and the reports. And if you have the opportunity to improve the cycle, because everybody knows that the lyos cycles cost a lot of money. It's a lot of energy, a lot of time, and at the end, if we are able to reduce these cycles in the future, it will really help, for the company and for the environment as well. So this is one of the important things, of course, for measuring in continuous process monitoring, but also what happens when we have a deviation. Here we have an example. This is a normal cycle in the right side, and here in this cycle, which is the same product, the freeze dryer fail, the chamber pressure go down, and then automatically the freezer reacts, freezing the product and going down until the problem was solved. If we have this problem in a freeze dryer, which this is a vacuum fail or another problems could happen that makes deviation in the behavior of the cycle. If that happens, we can lose the product. And we know that for commercial batches, maybe we have products with very high value, and it's a high investment to refuse a batch. On the other side, we have to go with some samples per shelf, go to the laboratory, spend our time and money in the laboratory, analyze all the data, and maybe we are able to save this batch. Using Tempris in commercial batches, it helps. Here, for example, was a real example the vacuum breaks, and the product starts to freezing. But thanks to the measurement of the temperature, we can confirm the product was completely dry at this point when the freeze dryer when the vacuum fails. So we're reporting to the authorities with these values of the temperatures, we can help a lot and reduce time and efforts to confirm that the batch or the product stays in the good conditions. This is one of the most important things when we have deviations, and we know that deviations occurs in the freeze dryers, one per year, 2 per year, etc. And using this technology, which is very easy to use with continuous process monitoring, would help also to save these expensive batches or these large batches that we are doing in our freeze dryers with especially for the large applications. So basically, it's this. It will help a lot for save these batches that we discuss. Regulatory also. I'm not the one expert in regulatory, but probably some of you, if you read these numbers, 32P2, 32P23, you are familiar with this. Now, here is another step where Tempris can help also, to bring the product to the authorities and to comply with all the regulatories. Is always a request. I will show later on a request from FDA is doing continuously that it's missing always temperature data of the cycle is missing. We close the door. We have silicone oil going through the shells. We have a vacuum or Pirani measurements, but this is not enough to see exactly what's going on inside of vials. In every vial, it's not possible, of course, but it's possible to control in these critical positions. Then the fully integrated solution is the upcoming technology. Very interesting to know, and it helps a lot, especially now when companies we are suffering with the next one coming. We hear about the next one many years, and now is there. We have a time to improve our installations, and it's a hard time, and some installations for new installations, of course, everything could be done. But for the existing installations, we have to find out the solution to avoid this, to be in compliance with these rules for the next one and next 15 as well. Here we have a short video that I will show, and it's basically automatic loading line. It's a project made in Switzerland with a customer. Is running this system. We present this project in Pharmatech. It's a conference here in Germany about lyophilization and pharmaceutical applications. And basically it shows here how we can help to be compliant with the next one with a fully automatic installation for including measurement points, of course. Here is the time. This is a single line. Normally we have single line for loading, and we have also another lines that, depending if the product allows us to do it, with a parallel line, like a parking place, so we have more time to place the sensors. But in the single lines, we have to stop the line and put the sensor, change the stopper and put the sensor. And this man here, this robot, is able to do it, replace the sensor or put the sensor with, replace the stopper and put the newer stopper with the sensor in only 28 seconds. So this is a very short time that, so we keep the loading line, stop it just for 28 seconds for every sensor. So I'm sure that will not affect any product or some products are very sensitive to the temperature and have to be loaded immediately to the freeze dryer. Let me show first this. This is a short video demonstration in real time, and let me show you this video also, which is basically the general concept of an installation. So I'm jumped this part because it's exactly the same that we show. Again, precise measurement because we are measuring in the center and bottom where the remaining ice is. The inside of the sensor, we have the quartz crystal just in this bottom part of the sensor, and we are not bringing any heat input to the product, as I mentioned before. We can use this technology for new applications, and we also can retrofit freeze dryers, installing the antennas and using our technology as well. So this is the video that we will see in detail. This is from another point of view from the camera. We can see that the robot is taken from this holder of the sensors, like I show in the sensors assembly. It's taking the sensor, is centering in 2 axes. Also, we can identify here which sensor is going. And with the line, we count, of course, it's not going over the flow of the loading line. And then he comes here, take the stopper, and put the new sensor in the corresponding vial, which is easy to identify with automatic loading lines because we have a counter which is counting the vials. The position of the sensor, the identification from the sensor, this information can go to our system and can be shown in the report. Then here a simulation of a freeze dryer, what's going on when we have already the sensors loaded inside of the freeze dryer. So we have here starts the process. We send the signal to the sensor starts to get measurement. The freeze dryer is start to cooling down. And then also when the process is finished, we can show how is the stoppering process, and the antenna is bended without any interference with the other vials. I have another extended version of this video to show all the steps here, basically how to load, how we showing the temperature, how we do the stoppering, and how we reject during the unloading of the vials our sensors. And basically here is the same video, and we can see that the robot is doing exactly the same. The previous video that I show is exactly the same, but instead of using a robot, we need this parking place for the sensors, and with the wraps and our special tweezers, a special design for using wraps, we can also take the stopper and remove the other stopper and put the new one in the vials in a manual way. Also, there is the possibility to go with the sensor near of a reading point, so we can identify the sensor without taking care if we take the channel 1 or 5. If we identify and we say where it's going, we will get in the report all the information and all the mapping temperatures together. Okay, again, centering for positioning. Of course, the vials, this is 2 air vials, are very small, and the sensor have to be fitted in this. That's why we have to center it with the robot, also the X and Y axis position, a part of the possibility for reading the sensor. Then replacement of the stopper and goes. Very, very simple, and this process repeats again. Some images with a zoom a little bit, but basically this is very helpful, this automatic loading line, if we want to do also continuous process verification or monitoring regarding the temperatures. Last point here in this presentation is it's related, so it's total quality control, but it's related again with the critical positions. That's why we are doing a lot of emphasis in this topic, because it's the most important. Many customers are coming, I want to measure everywhere in the freeze dryer, and okay, for me it's good to offer 40 sensors, which is the maximum number of channels that we can offer for one equipment. But of course, why would you want to measure in 40 positions? No? Why we are not playing with the system, identifying this critical position in the freeze dryers, and maybe 8 sensors or 15 sensors are enough for your large freeze dryer, because we want to measure in this hot, we want to identify these hot and cold spots inside of the freeze dryer. With this measuring these points, we can identify that if our cycle, our product during the cycle, is going through this design space. No, at the end, thanks for the measuring these critical positions, we will have the top temperature and the lower temperature during all the cycle. So if we will be able to identify if this is following our design space defined from the beginning, now from our process in the lab application also, and later on in the commercial applications. many studies and also allows us measuring in these points to identify if we are okay with the cycle. Also, we can make it a little bit shorter. No, this is also always comparing these measurement points with the design space during the first steps of our LIO product until the end, no? Conforming with the different freeze dryers during transfer and scale up. Basically, there are some parameters, of course, no, the appearance of the cake or the form, etc. But if you keep at the end the product in the design space, you will be able to confirm all of these parameters. And basically, at the end, we have many case studies done in different customers. Here we put just an example. Is already available in our website. That how happy was this customer using this technology for various low volumes. I think it was 0.2, 0.3 ml only filling volume in a vials, and how they get a robust study, robust cycle for this product. No, this is only one example. More information available in our website in references, and this is just a feedback from the customer. Also, on the other side, we are finding out also this is one of the presentations where FDA is participating, and we are coming always to the same message. No, we need more information. If as more information we have, we are able to improve our cycles and to be sure that everything is going in the correct way. And then he's always insisting. This person from FDA is always insisting that there is limited product monitoring. We measure the freeze dryer, we measure the pressure, we measure the flow maybe, but everything is general. But what happened exactly in the vials? No, and we have an idea with the other measurements, but of course the product temperature is one of the key parameters that we should have. No, and the conclusion is always the same, that we need more information and we need a real time product temperature. No, in our systems, in order to be sure for deviations as well, for formulation, for scaling up, and for transferring to control our product in the design space, etc. As a summary of this presentation, what the most important, I repeat again, if you can measure it, you can manage. We need more information, much easier to control. We have an examples with PQ test. If you are starting with the test from the beginning with a formulation, few people is able to identify without product temperature and to get the right PQ test without long experience. But with Tempris, this step is much easier as well. No? Quality optimization of the entire life cycle. As I mentioned, from the beginning, from preclinical studies lab until the end, we are able to control very good the product temperature behavior, the product being in the design space or design space configuration as well. And of course, if we are able to control this, we will be able also to reduce or improve our cycles, saving time, energy, and at the end is saving money. This is an additional one, but basically the key features: automatic no-hit input to the product. This is a very important point that we have to mention. Fully integrated solution with real-time monitoring of our LIO cycles. Easy to scale up and transfer to another freeze dryers. Same technology, comparing the same results with the same tools is a very important thing. And all the information reporting about our cycles, we will help also in case of regulatory aspects, in case of deviations, etc. So here is the main presentation, and then I want to show you. I would like to show you some additional solutions for antenna installations. I have here some presented. Let me show you. Any questions at the moment? We don't need to have a short break or whatever with questions.
Oscar.
Yeah.
There was a question from Roger Liu.
Mm-hmm.
So they've seen Tempris before, but the problem they are having now is that the vial they are using has a height of 75 millimeter, but the clearance is of the shelves is 81. So the space is only 6 millimeters. They are wondering if the antennas can be that short, or if the shortest is longer than 6 millimeters, and it will bend, and will the temperature or the receptions get affected?
Mm-hmm. Well, we are talking about 75 millimeters high, the vial plus stopper, right?
Just 1 second. Roger, 你好。您刚刚说的75是 vial 自己还是加上 stopper， 就是半塞的时候的高度啊？
Vial and half stopper height. Total height.
Okay.
Yeah, total height.
Okay, total height with a vial and a stopper, right?
Yeah, because the only one question is if your sensor up to the vial, this stainless board is bent, is effective the temperatures receptor your sense is effective your signals translation.
No. Then we have to consider the following: which filling volume we have. The first thing that we are asking. I have also a questionnaire that I can show also what is the information that we require for offering the right product. When we have a 75 millimeters high vial, we would like to know the form of this vial, if it's a standard Air or H vial, or at least the data sheet. And then the other important thing is to know the filling volume. If we have a large vial, but we have a very low volume, maybe also we can use the small sensor. I'm talking first of all without configuring any specific solution. The small sensor, for your information, from the antenna, without the pin, of course, the body of the sensor, the TL12, is just 14.1 millimeters high. 14.1 plus 50 millimeters of the antenna, so we are in 64 millimeters. Plus the bottom part of the vial, the bending part and the space, let's say maximum 2 millimeters, so we are in 68 millimeters. We have still place until the 81 of the shelf clearance. We have solutions for 74, small freeze dryers with 64, 74 millimeters shelf clearance, and the antenna is not reaching top. If there is any other specification and we need a large vial and the antenna have to be shorter, we can then also configure a special antenna, maybe thicker but shorter, to get the best signal. Basically, we need this 50 millimeters for the concept of the radio frequency, have to be 50 millimeters length, but also we can improve the form of the antenna or whatever in order to fit the vials. 81 is not a critical shelf clearance for us. If we are talking about minus than 60, then of course starts to be complicated. But for 81 millimeters, we will find out the solution. So feel free to provide us the vial details and the filling volume, and we will propose which one is the most convenient solution for measuring here.
Hi Roger， 这样有回答到你的问题吗？
就是我比较好奇是，虽然说考量到那个毫升数，但是所以他的意思是说，其实它上面还是不建议要就是被弯曲的是。
对，就是我很多个选择，可以不让它被弯。对
OK，
applications.
I know it also should be considered about the feeding value. You can choose select another maybe small sensor to let the rod up the stopper expand or not.
Sorry, I don't know. I'm not sure if I understand the question.
So the most important, you say it depends on the feeding value, and we
Yes.
can select small types of sensor. It can avoid the rod up the stopper, your sensor up the stoppers is bending.
Yeah, when we are doing the stoppering, this antenna that we can see here in this image will be bended. Huh?
So you don't recommend list the up of the stoppers is bending. It maybe affect our signal translation.
Well, basically, yes. Of course, the radio transmission works under polarization, and we have to have the antenna vertical, completely vertical. But when we are doing the stoppering, means we are closing the vial. No, the antenna will be bended 90 degrees, completely 90 degrees, and then after when the shelves go up again, the process is finished. Normally, the process is finished because the vial is closed. The antenna will come back something like 45 degrees. Sometimes we can still get the signal with this 45 degrees, no problem, because no liquid phase, everything is dry inside, so it's much easier to get the data. However, we have the antenna bended 45 degrees, which reduce the performance. But basically, are you also interested measuring the product temperature after this stoppering process?
Sorry.
You want to measure always? You want to control the product temperature after the stoppering process, or not? Just
No, it's not. Just
no. Okay.
Yeah.
Sometimes we get the signal. Yes, we can get some sensors depending on the location when the after the stoppering with antenna is bended. But of course, this is not the normal one. When we don't need to measure any more product temperature. But in any case, here we are talking about 75 with the stopper, and we only have 6 millimeters more to the upper shelf. So we will have a very short part of the antenna outside of the stopper. So the rest will be inside and will be dry, no liquid. So also the signal goes through the glass not in the same way, but also can go through the glass. So these are not a big problem with 81. The only thing that we need to know is normally we talk big vials, large sensor, but sometimes we have customers for specific products that they have large vials with very low volume. So in this case, they don't really need, they only need maybe an antenna extension to reach the stopper, but they don't really need a long sensor because they have a very low volume. So feel free to provide us this data, the vial and the filling volume, and we will configure, and we will come back to you with the right sensor antenna, sensor and accessory solution. No problem. The 81 should not be a problem of.
Okay, so the sensors also can be customized.
We have different types. We have the TL12 for the 2R vials, typical for 2R vials. Then we have the 18th, which is already 21 millimeters long. Then we have the 28th, which is this one. Then we also have a TL6, which is a prototype that we have for these double cartridges, but for very thin double chamber cartridges or syringes. And then we have the large ones because we have customers that are using 100 ml, 250 ml bottles. And we have the 48 and 58, where we are going over 50 millimeters length of the sensor. The easy way is always pushing the sensor up, but then we are losing the critical measurement point. No, that's why we have to keep measurement point in the bottom, because this is the part where we want to measure, and then the only thing is changing the sensor body or going a little bit up to be the top part over the liquid.
Okay, understood. Thanks.
No problem. So I have here the presentation. I want to close this, and I want to show some of the solutions that we have for the freeze dryers, for different freeze dryers. Here is for the small ones, lab and pilot freeze dryers. So we have antenna solution, which is the configurable part. mainly we can configure other parts as well, but the most important is how we get the signal from the freeze dryer. We need special antennas for every application. So in this case, we have here the lab pilot freeze dryers, for example. System configuration is always the same, but in this case for lab pilot, we can use internal, external antennas depending on each one. Let's see what we can do. System will look quite similar than before. The software is the same, but with the basic functions. Normally, also we have pilots with the complete software requirements and IQ, OQ documentation and execution. And then the interrogation unit, the main system, is not necessary to be encapsulated because it's not installed in top of the freeze dryer chamber with the rest of the instrumentation and it's a mechanical room, it's not a clean room or let's say desk area, maybe we can call. So that's why we use this housing with, could be also fixed in the wall or could be also put in the top of the table, no, top of the desk near of the freeze dryer door. Then the antennas, I will show the different configurations. Could be golden plate antenna using sample tip freeze dryers or external antenna for side glasses or acrylic door when we have no way to go inside of the freeze dryer. We recommend always internal antenna. The signal performance is much better, but sometimes we can also use external ones. Here is an example, for example, the one freeze dryer Livestar 4 with 3 antennas inside, install fixed installation, or we can use also the big 8-inch side glass. Another freeze dryers with sample tip, we have this golden antenna installed inside. With this meta glass, we change the meta glass, and some freeze dryer with a sample tip, we have also solution. We are able to install the antennas inside. Acrylic door, 2 external antennas, and we recommend to cover with aluminum foil or with a metal plate the rest of the antenna at the door. Big side glasses also. Small side glasses also, we replace the flange and we put internal antenna. Acrylic door with sample tip in acrylic, we have a very small antennas and we put 2 in the corner. This is the only place that we place and we can put the antennas. Another all freeze dryers with a window. Another freeze dryers with a flange, available flange in the door. We only have to replace the flange and install this antenna. Again, everything installed inside will be stainless steel. The antenna is golden plate. So everything suitable for sterile environment, even when it's not, in this case, maybe required. We can go also with the cable through the wall. We have a special features and we can have the system on the other room. No problem. Another type of freeze dryer with acrylic door and a second metal door. Some customers require a second door, not for Tempris from the beginning. They are requiring for heating dissipation. They want acrylic door and they want a metal door for lab pilot applications. And then we can change this metal door for a door with some cavity or some space. And then we are able to install the antennas inside also. Not inside, so it's still outside, but covered with this metal, so we don't need to cover with another plate because it's already integrated in this door. And here we can see that the main system could be installed near of the door, in a wall, for example, or in a table. Different options. This is more or less some solutions example for lab applications, and then for commercial freeze dryers. I show already during the main presentation something, but I have here some clear pictures how it looks, these antennas for these commercial freeze dryers. No, basically system, it was already mentioned, one or single unit or double unit could be with 2 housings separately, because we always want to place this main device near of the fit-through available where we go with the cables. So we can separate in 2 systems, one of near of one flange and the other near of the other flange available. Also, we have a little bit bigger housing with the 2 units when we have more than 6 antennas. With the 2 units in the same frame, in the same housing. The antennas, we say here more for retrofit, because normally when a freeze dryer is existing, it's difficult to install this MFA solution. Depending on where are the flange available, of course, if we have a flange available in the right position, we can connect the connection tube to the flange and then put in the external components outside. Or we always can use this antenna, which performance is the same. Maybe the one with the tube have less maintenance because have not cables inside of the chamber. See, no, everything is integrated in a tube. The cables, for example, are in Teflon cover, supports sterilization cycles as well, and the connectors are in 316L stainless steel. The guiding for the cables are also 316L, so everything is compliance for SIP and CIP cycles in the freeze drying. And the sensors, of course, that we talked about already. And then we are in this part, in commercial solutions. So we have, for example, starting with this tube antenna, the MF antenna, a sample of installation coming the connection tube from the flange. We have this tube installed. Here another example with the main units. You can see the antenna here, the main unit connected with the antenna tube very near. We have two housings, in this case, 2 units, because it was a large freeze dryer. This is a medium freeze dryer, and we place antennas in all the shelves, in exception the last one, because there was something like a pusher, I think, in the freeze dryer. So we have 1 antenna per shelf, fully integrated in this freeze dryer. This is a large freeze dryer, something like 40 square meters with a fully integrated solution. It was the photo that I showed before, but here a little bit bigger. We place 1 antenna with 8 antennas, 1 tube, 1 MFA with 8 antennas in the left side, and the same in the right side. So we can install in total 16 antennas for this complete freeze dryer in order to get the best performance. This antenna could be rotated also in order to point more from the left and the other more from the right in order to cover the complete shelf with a signal. Even when we get signals via reflections, we optimize the position for getting always the better performance of the system. That is how it looks between the shelf clearance. We have an antenna pointing to the sensors. Here some specific holders for test, keeping the sensors in vertical position. And here the other version, the antenna PH1, which is with the cable. We can see here going from the flange the cables to the specified rod. Freeze dryer manufacturers are building this rod for us when it's a new freeze dryer, or we can install one by ourselves, clamping in an available CIP pipe. These are the antennas without cables. Here is also how it looks, the antenna. It looks very near. Of course, we have to keep some distance from the shelves. We avoid any possible risk of collision between antennas and the moving of the shelves, of course. Everything is calculated, very precise, to avoid any damage of the equipment, from our equipment, from Tempris equipment, let's say, or from the freeze dryer, of course. And then here how it looks, for example, some installations in the condenser side, which is not the most recommended, but it's a very small plates are perforated, so they are not affecting really nothing in any flow, sublimation flow, especially for such a large freeze dryer. And then the cables coming, always doing a loop and coming for every antenna, completely guide, and to avoid any risk of touching moving parts of the freeze dryer. This is a zoom of the antenna, stainless steel. Everything that we can see is stainless steel, in exception the cable, which is Teflon, and the connection of the antenna, which is golden plate. Everything suitable for sterilization, cleaning agents, etc. 2 systems without cover, how it looks. The main one with the power supply is power over Ethernet. So we have to bring here 2458 volts DC, and the unit is able to give power to the main unit and the subunit device. And we also can connect here our laptop via Ethernet cable. And always recommendation to place the main systems very near of the available flange, in order to reduce as maximum as possible the cable length, the radio frequency cable length. Here, for example, a study of a large freeze dryer, 14 shelves. We place 2 systems, and we place antennas in different sites, depending, which is also very important, where we want to measure in this freeze dryer. Where are the requirements from the customer, or where we want to measure? And then as much points we want to measure, of course, we need more antennas. So we have to focus, we have to balance the system configuration by the requirements in order to get the best solution. Here we install the units very near of the hydraulic system from the shelf moving. Here we can see the guidance this is a new freeze dryer, so they build some guidance for the cables also coming from the flange and going to the different rods or holders for the antennas. So we can see here we place in this side in shelf 1, 2, 7, 13, and 14. So one in different mini rods, let's say, attached to the existing frame parts of the freeze dryer. And on the other side of the freeze dryer, in the opposite side, we have placed 3 additional antennas in shelf 1, 7, and 14. This is a little bit zoom how it looks. The manufacturer designed a special holder, fix it in these rods, which are the guidance rods for the shelf movement. And this is more or less a 3D view how it looks the antennas installed in a zoom. So more or less the intention was some antennas here, some there, in order to cover this area and this other area in different configurations, depending. That's why it's very important to configure which is the vial size and filling volume to know how much water we have inside, and then where we want to measure. And if we say everywhere, then we have to put so many antennas and the price of the system increase. So we always have to balance what is the requirements, what is the most suitable option. Okay. So last one I have here. I can show 2 things. One is the questionnaire. What are the frequently questions that we need to know, or the information, the specifications that we should know about the freeze dryer in order to prepare the best solution. Basically, we have a standard questionnaire about the company, whatever. What is the intended use of this freeze dryer? If we are in the lab sector or we are on the commercialization and real-time monitoring, or no, I only want for validation, or no, we want to have this system for everything. How many sensors, which range of calibration. We didn't talk so much, but the standard that we are offering is -60 to +40. We calibrate under 6 points, 6 measurement points, our sensors. Accuracy, of course, I mentioned 0.7, but then also we can offer -60 to 60, -70 to 70. For lyophilization, it's the most common ranges that we are offering. We have another solution for sterilization, which it goes from, normally the range goes from 20 to 140 degrees. We want integration with the SCADA, yes. Which type we want? Also, some possibilities with OPC, UA communication for Historian or other softwares. It's also possible. We need this campfire requirement. We need IQ-OQ. This is more or less we mentioned. And then the most important is the freeze dryer manufacturer. We need some data now, how many shelves we have, which shelf clearance, as we discussed some minutes before, the dimensions of the shelves, depending if it's a big one, we will recommend always antennas in both sides. And the total shelf surface at the end is the amount of the liquid or the vials that we will put at the end. We need to know this, and where are the flanges available? This is very important for installing the systems. Where are and how many we have and which type. We have solutions for everyone. Pre-clamp, KF, ISOCA. We have flanges of every time. Side glasses converting to meta glass. So you keep the glass, but you have also the metal for these fit-throughs. So we have all possible combinations. And here is one of the important parameters to configure the sensors type and the accessories is to know the vials. Which type on other vials. If in any specific, always better to attach the data sheet so we can calculate these measurements and how high is the volume with sensor or without sensor. It doesn't change so much. We saw here a volume of the sensor inside of the vial, and we think that the volume of the liquid will grow a lot, but it's a really few millimeters for up or 0.1 millimeters, few of them, 0.1 millimeters when we immerse the sensor inside of this vial, because it's just the measurement point is 2.2 millimeters diameter and the body is 4 millimeters, I think, diameter. So it's very thin sensor, specially designed for lyo products. So these are the short question. Then we have another extended when we go forward, but for an initial proposal, this should be enough. Oops. And then I have here, I want to show what happened when we have the software installed in the computer, no? In our computer, in the freeze dryer, computer, in a server. So we need a software to manage our system. No, basically, we will have an icon with the Tempris logo, which allows us to open the software. No? You will see how easy it is to manage this software. It's quite simple to use and very intuitive and very helpful. Basically, we have here text. At the moment, we have nothing because we are not connecting with any system. Remember that this is a demo version. The temperatures are showing are false. It's just going up and down to see what's going on with the temperatures and how are shown. So first of all, that we have to do is, after opening this file, we have to connect with the system. No, the connections are already configured. Which IP address we have in the system and we have in the laptop have to be in the same family, only changing the last number. And then we connect now. And then it's asking, okay, is this you want? 192, 168, 100? Yes. Normally, when we configure one time, we don't need it anymore. Then when we have a 21 CFR Part 11 GAN5 software compliance, we have 3 software licenses. We have Audit Trail, we have user management, and we have backup. The system is generating an additional copy of the files for safety reasons. And when we have a user management, of course, we have different users. And of course, it's asking for a password when we are trying to enter. No, this is a demo version, so I can put whatever is the password, and we go in. Now we can see that the system have configured these channels. So we have 6. For example, 12 and 16 channels configure. We can configure the colors. This is fully configurable. I will show you how to do it quite quick. Channel number, serial number, identify the temperature, and which antenna is catching which sensor. So normally the thing that we will do immediately will be we start the software and we start measuring. We switch F7. Or we come here to start measuring. Also, I don't know if this demo version have also the Chinese versions available. I'm not sure if this is the traditional in this demo version because this demo is not the latest version, but at least we can start measuring. It's asking for a comment about this cycle. For example, we can say batch 1 or whatever, doesn't matter, just one number. And then it's calibrating the antennas. It needs a little bit more time in the normal conditions, and then start measuring. And then the temperatures are here. For example, channel 4, 15 degrees, antenna 4, and this is the serial number, which is not changing this demo version. And of course, these temperatures are reflected in a graphic as well, in real time. We simulate here. A radio frequency is not a 100% signal. We always have to consider it's like the cell phone, no? If we are talking with a cell phone and we are going, for example, downstairs in our building, maybe the communication is lost or it's difficult to get. That's why also with our technology, we have to consider which level of the signal we want to get and which shelf we have, which volume, and then how many antennas we place and in which position is possible in order to get always the most highest percentage of signal acquisition. When we get the signal, is in white color. When the sensor is lost for some reason, we change here in the demo version every second we are changing one. You see that change to gray color, so it means we lost momentaneously this sensor. The temperatures are going. In this case, it's going up and down, but normally we have something different. Here we have all the channels, and of course in configuration we can change all colors. We can deactivate all the sensors, showing no one or just showing 2 or 3 sensors, for example. We can show all of them with one switch. We can show also maximum and minimum temperature. So we can see if the sensors are going, this maximum minimum fits in our design space of the product, for example. And then I will have problems to translate this from Chinese, but basically we can show points or lines for the product temperature. We can show normal time, starting from the normal time or UTC time, UTC or normal time could be configured as well. And we can, I have problems to translate this, sorry. I want to show you in Chinese to be easy for you. But basically we can put also relative or absolute time. So starting from 0 or starting from the real time, no? And here we have all measurements. Of course, everything can be configured, and with the wheel, in the mouse wheel, we can switch and make a zoom from a specific part. We can remove zoom, we can make zoom, or we can come to the original, all data that we have at the moment. Everything is configurable. Also, when we are measuring, we also can start logging. No, we are measuring, and the data, it goes, if there is integration, it goes to the SCADA, yes, but it's not. We are not having any safety copy. No, then the most recommended is also start logging. It's asking, is this cycle with this comment? Yes. You want to add any comments? You want to select any template, because the batch report could be also fully configurable. We can create fields in the report that I will show later. So it's a tool that we can easily configure, and we can select different templates. Here I have a per defect Tempris template, but we have another up to 16 fields could be configured in the template. And then we say OK, and then it says where do you want to save this, and we say OK here. We are saving this log file here. Now all of this data will be saved in our desktop, in this case in my desktop of my laptop, or in your case whatever you want, in the server on your laptop, whatever is connected with the system, you can select the folder, the preferred folder for saving. When you have the backup software, even login or not, you will get always a safety copy in the SD card, which is integrated in the main system. In case of the system lost the communication with your laptop or with your freeze dryer control system, you will always have this backup copy in the SD that you can easily download and export and show here in the screen. And from the screen, you can export to log file report in PDF, or you can export to CSV file, for example, with temperature values. Once we have a measurement, we can basically stop logging. Are you sure? Yes. And when we also can stop measuring. And then whatever we are showing here in the screen, we can basically go to, I think it's here, we can export to CSV file. We can check the measurement statistics. It means every sensor, we have a total of 68 measurements, I think. And then is here the measurements for every sensor. Okay, here started a little bit later because we started to log in a little bit later, but basically it's getting it says 80% because this is the 55 versus 68 in this demo version. So we can see which sensor and which percentage and which antenna. In this case is only one. Normally we get the sensors for different antennas, and every antenna is participating in a different percentage. When the cycle is finished, we can take the laptop and go to our desk, and if we have this report saved here, we can disconnect from the system, and we can go to log file. We take the log file from our system, and we get it again in our screen. And here from our screen, we can go to generate our PDF report. This PDF is this one is saved here. We can configure this PDF and say, what do you want to show here? Which time, relative, absolute, UTC or not? The graphic for all the sensors, the graphic for every one graphic for every sensor, temperature. We want to show the statistics, and we want to show and we can select whatever we want to show, all the mapping of temperatures in PDF. For example, we can say remove the single and we show only one graphic, and we select these options. Here we can configure the header and the footer with your logo, with your comments in the report, and you can add the logo of the company if it's necessary as well. We say okay, and we create the PDF. And the PDF looks like this. So we can configure the header. We don't put anything, and the logo will appear here. So this is the running cycle. This is our comment, and here we have 2 fixes fields to fill it out, but we can add up to 16 fields in our template of the report. So we can put all the fields that we need in order to control to get more information in the batches. No, we can put, for example, batch and a defect value of the batch. If nobody's writing anything, will appear the defect value, or you write here. Then when you start logging, they will ask which batch is the batch 44. You put 44, and you will get here in the report as well. The second page of the report shows all software license installed, which software version we have, which antennas we have connected, which is the user, the admin, the Windows is me, for example, and also here more information. This is not appearing here in the demo version. And then the sensors, serial number, calibration date, and do-it-to date for next calibration. And the calibration range will be -60 to 60, for example, will appear here. No, which order we have, channel order and channel number. Could be from 1 to 40, the channel number. And then in the next pages, for example, we have the measurement statistics for every sensor, because we select this option. And then we have the graphic. We only select the graphic, all sensors in one page, but we can have one page for everyone. Remember that is optional also. We can configure. At the end, we have all the temperatures as well for all the cycle that we get. That's the report that we can generate. Then of course, we need to connect with the system. And then there is the settings, and we have different settings to configure. Of course, depending on the software that we have installed, we can configure how many sensors we have. We want to delete these different sensors. We only have these ones. We only have these 2 antennas installed, or we have 8 antennas, depending. We want a measurement interval, 1 second. Normally 1 second we are not using. We recommend to go more than 10 seconds, depending on the cycle. Let's say we want a measurement every 15 seconds. And when we configure everything with information of the sensor, also we can get all the information of every sensor that we have configured. We can configure, or we can delete, or we can add new ones and configure, downloading the coefficient files for every sensor. And we can save the file with different files, different configurations anytime. And of course, we can upload. Today, we need only 5 sensors. We configure a file with 5 sensors for the product A. Tomorrow, we need 16 sensors for the product B with another measurement interval. We also can configure, and it's very important, always configure the system with the sensors that we are going to use. If we are not changing and we are always using 10 sensors, we save 1 time, and only we have to update this file every year after the annual calibration recommended. But in case we decide tomorrow to use only 3 sensors, we strongly recommend to configure only with 3. So we will go basically like this. We will configure the 3 channels that we are using. We will save with another name, and we will configure the file with these sensors. Otherwise, the system is trying to find sensors which are not available in the freeze dryer, and this is a performance consumption from the sensor that is not required and not recommended. Okay. So we have automation settings when we have the integration with the SCADA, which IP addresses, which type of communication, activate or not. So we can test also the communication with the IP address on the other side, etc., for the different channels. When we have automation, we also can see during the measurements how it's going, which is the output in milliamperes to the signal in case we configure 420, the range. We also can check this during measuring. So we have here all the license installed with the expiry date or non-expired for the final license. And also the users, we have some users, password, fully configurable password for every use. Administrator can create and delete different operator, listener, service. There are different levels configurable in password level, in password difficulties or password configuration. Everything could be configured, and everything, all the changes, if we have the audit trail, all the changes about new users or creating or deleting or registering, login, everything will appear in the audit trail report. And then we have, this is the upcoming news that we will be able to configure the freeze dryer type with the dimensions and also the product, which product we are using with the name, and which vials and which filling volume. This is the thing that will come with the new software version in order to have all the information. INET is when we have two units to communicate one each other, and also we can configure the IP address of the system. Basically, I just explain a little bit how it works, the software, and how what is what we can do with this equipment, no? So any questions here? For me, I don't know if there is any specific point we can go through this point. For me, I think I introduced already the main technology, how Tempris can easify your LIO process, how it looks, the installations, what is the benefits of using our technology, what we have to consider when we are using our technology, uses or levels of our technology in use for lab applications. I focus this presentation mainly in lyophilization, which is our main product. We have also another products like sterilization. We have also solutions for granulization, called topo machines for make this product for tablet products, for example. Also, they want to measure how is mixing the product, the temperature. We have different applications, but the main one is the lyophilization, and this is the one that I introduced today to you. If there is any question, please let me know, and I will answer as much as possible. Or also, if there is any question that comes later, the colleagues from UTEC will take all the questions, and we can also have another meetings later on, or we can by email. I can send additional information if it's required.
Thanks to Oscar for this presentation.
Mm-hmm.
So,
thank you to you for organizing, and for all the people present here.
是感谢各位贵宾的参与啊。那如果现在没有问题的话，我们的这个今天的 conference 就到这边结束了。请问有问题现在想问吗？那好，如果现在没有的话也没有关系。那会后我们会发送一个连接，它会有一个表单可以请你们填。如果有任何的问题，都欢迎在那个 Google 表单填上，我们会尽快的回复你们的问题。好，谢谢。Okay, thank you, Oscar. Seems like there's no questions at the moment. So yeah,
okay.
And if there's any, I would transfer to you.
Okay, thank you very much, everybody, for attending. I hope it was interesting for all the participants. So talk to you soon, and 谢谢。
谢谢 ，Thank you。
谢谢。
好，谢谢各位。
拜拜。